Hello students, how are you all? Today we are going to start the next chapter, that is application of derivatives. Applications of derivatives. First we will discuss some formulas which we will use in this chapter. Area, perimeter. Area of rectangle. Area of rectangle, length into breadth. And perimeter of rectangle is 2 times L plus B. Square. Area of square is side square and perimeter is 4 into side. Area of equilateral triangle. Root 3 by 4 into side square. And perimeter of equilateral triangle, 3 sides are equal. So we can write perimeter as 3 into side. Isosceles triangle, half side square. If 2 sides are equal, that is A and third side is C. Triangle, half base into height. And if the sides are ABC, then perimeter is A plus B plus C. Next is parallelogram. Area of the parallelogram is length into altitude. And perimeter is 2 opposite sides are equal and parallel, so 2 times L plus B. Next is, note up to here first. Rhombus. Area of rhombus is half product of its diagonals. Half products of its diagonals. Rhombus की चारों side equal होती हैं, so perimeter is 4 into side. Next one is, after parallelogram, trapezium. Half sum of parallel sides into height. Half sum of parallel sides into height. Next one is circle. Area of circle is pi r square, where r is the radius, and perimeter of the circle is 2 pi r. Semicircle. Area of semicircle 1 by 2 pi r square, and a perimeter of semicircle divided by 2, that is pi r. Side of rhombus, square, and side of square and rectangle. Side of rhombus किसके इक्वल होती है? d1 by 2 square plus diagonal divided by 2 square square root. Square की side is side of diagonal of square. Diagonal of square is 2 into root 2 into side. Diagonal of square is root 2 into side. And diagonal of rectangle is square root of length square plus breadth square. Clear? Now the next is about volume and area. Volume, total surface area and lateral या curved surface area. Clear? First one is cuboid. What is the volume for cuboid? Cuboid has three sides, length, breadth and height. Clear? Total surface area is 2 LB plus BH plus HL. Curved surface area is also same. Now, क्यूब. अगर क्यूब की साइड है एक्सपोज तो साइड क्यूब एक्स क्यूब. अगर साइड एक्स है तो एक्स क्यूब एंड टोटल सरफेस एरिया इज 6 into side square. Curved surface area again same in this case. Next one is cylinder. Volume of cylinder is pi r square h and total surface area is 2 pi r h plus 2 pi r square. Curved surface area is 2 pi r h. Cone. Volume of cone 1 by 3 pi r square h. After that, total surface area pi r l plus pi r square and curved surface area is pi r l. L is slant height, that is equals to r square plus h square square root. Next one is sphere. Volume of sphere 4 by 3 pi r cube. Curved surface area is 4 pi r square and total surface area and curved surface area is 4 pi r square. Is it clear? Now we will use all these formulas to solve the questions in applications of derivative. Note up to here first. Next, write down, let I be an open interval. Let I be an open interval contained in domain of function f, contained in domain of function n, then f is said to be, number 1, increasing on I if x1 is less than x2. जो दो पॉइंट्स है, x1 is less than x2 in I implies f of x1 is less than is equals to f of x2. The function is said to be increasing for all x1, x2 belongs to I. Function is said to be increasing if x1 less than x2 implies f of x1 less than or equal to f of x2. Strictly increasing. Function is said to be strictly increasing if x1 is less than equals to x1 is less than x2. It implies f of x1 is less than f of x2 for all x1 and x2 belongs to I. Third case is decreasing. Function is said to be decreasing on I if x1 less than x2 in I. It implies f of x1 is greater than equals to f of x2 for all x1, x2 belongs to I. Or we can say that function is strictly decreasing. This is sign for decreasing. If x1 less than x2 implies f of x1 greater than f of x2 for all x1, x2 belongs to I. Clear? Function strictly decreasing कब होगा? When x1 less than x2 and f of x1 is greater than f of x2. And if x1 is less than x2 and the function value at that point is also less than f of x1 is less than f of x2, then function. Or we can say that f is said to be increasing function, said to be increasing in AB if f dash x is greater than 0. अगर first derivative greater than 0 है for each x belongs to AB, then function is said to be increasing. Similarly, function is said to be decreasing if first derivative is less than 0 for all x belongs to AB. Note up to here. Next one is equation of a straight line passing through point x naught, y naught and having slope of tangent as m. Having slope of tangent m. Then the equation of tangent will be y minus y naught m x minus x naught. Equation of normal. First find slope of normal. Slope of normal is equals to minus 1 upon slope of tangent. Slope of tangent is dy upon dx. Slope of normal is minus 1 upon slope of tangent. So equation of normal will be y minus y naught minus 1 upon m x minus x naught, where m is the slope of tangent. Tangent is parallel to x-axis if slope of tangent is 0 and tangent is parallel to y-axis if slope of normal is 0. Clear? Now two lines are said to be parallel. Two straight lines are parallel if their slopes are equal, and two lines are perpendicular, orthogonal at right angle one and the same thing if product of their slopes is equal to minus 1. Now angle of intersection between two lines is equals to tan theta is equals to m1 minus m2, slope of first line minus slope of second, m2 minus m1 upon 1 plus m1 m2. Next, to find approximate value. To find approximate value फाइंड करने के लिए हम क्या करेंगे? डेल्टा y is equals to f of x plus delta x minus f of x. Delta y, that is dy. Delta x dx. We can write delta y as dy upon dx into delta x. Clear? These all are formulas which we will use to solve the questions. Now next is let f be a function defined on interval I, then f is said to have maximum value, then f is said to be have maximum value in I. f की function की value maximum कब होगी? If there exists a point C in I such that f of C greater than equals to f of x for all x belongs to I. अगर उस पॉइंट पे फंक्शन की वैल्यू गिवन फंक्शन के पॉइंट से ग्रेटर होगी, देन C is the point of maximum. The number fc is called maximum value of function, and C is called point of maximum, and f is said to have minimum value when f of C is less than equals to f of x, then fc is minimum value of function, and C is point of minimum. Now f is said to have extreme value. कब? जब fc is either maximum value or minimum. When fc is either maximum or minimum, then fc is said to have extreme value and C is called point of extreme. Next, write down, let f be a function, real valued function, let f be a real valued function C is point in its domain, real valued function, and C is any point in domain of f. C is any point in domain of f. C is called point of local maxima. C is called point of local maxima if there exists some point in the neighborhood h greater than 0, fc is greater than is equals to f of x for all x in c minus h and c plus h. C is called point of local maxima and local minima. Local maxima when fc is greater than is equals to f of x. Then fc is called local maximum value and c is point of local maxima. When fc is less than equals to fx, then fc is local minimum value and c is the point of local minima. Clear? नेक्स्ट इज अगर हम फर्स्ट डेरिवेटिव टेस्ट से चेक करते हैं कि फंक्शन जो है लोकल मैक्सिमा है, लोकल मैक्सिमम वैल्यू क्या है और लोकल मिनिमम वैल्यू क्या है, फर्स्ट डेरिवेटिव टेस्ट से चेक करेंगे. राइट डाउन Let f be a function defined on. Let f be a function defined on open interval I. Let f be continuous at critical point C in I. First case, if f dash x changes sign from positive to negative as x increases through C, as x increases through C, then C is called point of local maxima. When f dash x changes sign from positive to negative, then it is the point of local maxima. Second case क्या हो गया? If f dash x changes sign from negative to positive as x increases through C, then C is point of local minima. Then C is point of local minima when negative to positive. If f